we'll be looking at one more, I can say, part of control system, which is nothing but a block diagram reduction. This is one of the topic of control system. Let me place in this way. Now let's say that some block is given to me. I'm going to take a very simple, this is one of the basics of block diagram reduction. Now, in order to solve a block diagram reduction, in the books you might have studied so many methods. We're going to look at a different method, which is a very easy method to solve this. The only thing you should be knowing that in order to solve any block diagram reduction problem is two properties. I'm going to say property, but this is not a property. First, when blocks are in series, or I can say blocks in cascaded, let's say G1, let's say G2, then you know that the equivalent of this will be nothing but G1, G2. Because of time, I'm not able to focus on much. When blocks are in parallel, then the equivalent would be G1 plus G2. Another thing is a small thing which you'll be already knowing that. Let's say G, this is G, this is X, and this is Y. So X is the input, G is some gain block, and Y is output. In that case, you know that what is Y? Y is nothing but, I can say in Laplace itself, because most of the time I'm dealing with Laplace. Y of S is nothing but G of S into X of S. Now, if you are fine with this, I don't say basic properties are basic properties you would have already studied. I'm just saying that. So, if I know this much, I can solve any block diagram. Let's say how can I solve that? This is a negative feedback block. Okay. Now what I'm going to do is, if you see here, there is a block coming in, this is going out, and something else is also coming in. Now what I'm going to do is, I don't know what is coming in here, because there is something Y of S, something is getting here, and then something is coming in. I don't know what it is. Whatever I don't know, I'm going to assume that. Let me assume it as a K. Now what I know that, what is coming in from here? X of S. What is going out? It's nothing but, can I say that it is nothing but this minus this? So let me call it as this call as a K1, and let me call as a K2, because these two quantities are unknown to me, so I'm going to assume something. So this is K2. So can I say that K2 is nothing but X of S minus K1, because you see, right? This is nothing but this minus this. Exactly, it is easily visible, right? Now, so, and what is, so I got K2. Now, one of the properties which I showed you like this, if this is X, this is G, and this is Y, then you know that Y is nothing but X times of G, right? So, can I say that K2 is getting into the block and it is giving me Y of S? So, can I also say that with the same property, K2 times of G of S is equal to Y of S, right? Same thing, K2, G of S is equal to this, X into G equal to this. Now, looking at the same property, can I say that if you look at this part, Y of S is this point. It means, can I say that Y of is this which is coming in, because this is what, it's a unidirectional flow here. So Y of S is coming into this block, and then it is giving me K1 of S. In the same way, K1 of S is an output here. So can I say that K1 of S is equal to, input is Y of S at this point into H of S. So basically I got K1 of S, so I got some equation. Let's solve this equation. Now, can I substitute K1 into this equation? So my equation would become, let me call this as an equation 1. So substituting this value, so let's substitute it. So K2 will become X of S minus k1 value is y of s into h of s. Now I can substitute k2 also. K2 is nothing but y of s by g of s. So y of s by g of s is equal to x of s minus y of s into h of s. Solving that, cross multiply, y of s is equal to x of s into g of s minus y of s h of s into g of s. Further I can simplify this. So y of s, taking y of s in one side, so y of s common here, this will become 1 plus h of s into g of s will become x of s into g of s. Now I can take, what is a transfer function? Output by input, right? So I can take that common, so it will become g of s by 1 plus g of s into h of s. And that's what we have derived the transfer function in case of a negative feedback system. Thank you guys.